Hello everyone. Let's move to the next topic, mixing chambers. This is another typical application of the open system. So mixing chamber, you may have seen this kind of device in your bathroom, right? So you have a hot water supply, you have a cold water supply, and then you can take the shower. For this type of device, basically we will assume the system there is no heat exchange between this system and the environment, and apparently there is no external work involved, and the kinetic energy change can be considered as zero, and potential energy change can be considered zero as well. So you may wonder, the potential energy change, it seems it's changing, right? Because the exit number 3, it has a higher elevation than the inlet 1 and 2. But this small height change, it won't cause a significant energy change compared with the enthalpy change. So we still ignore both the kinetic energy and the potential energy in this case. But this case, we have 2 inlets, we only have 1 outlet. We have to consider the mass conservation law, which is M1, the mass flow rate from the inlet number 1, plus the other inlet number 2, M2 dot, equals the total flow rate from the exit from the outlet number 3. And since we do not have, regarding the energy equation, we do not have Q dot, we do not have W dot, we do not have kinetic energy, potential energy. At the end, the only thing left is the enthalpy. So the enthalpy energy equation regarding the enthalpy is M1 H1 plus M2 dot H2 equals M3 dot H3. So this is the equation for a regular mixing chamber. If it's a specific mixing chamber, for example, if in a exam problem or homework problem, say there is a heat transfer to that mixing chamber, then we need to consider Q dot. Or if there is a blade or propeller something running inside to mix the liquid, to mix the flow, then in that case we may have shaft work. For example, if a mixing chamber is something like this, so this is the outlet and we have 2 inlets, 1 outlet. But to achieve a good mixing performance, we may add a device like this and let it run, right? In this case, it can achieve a better mixing, but in this case, W dot is not 0. We need a work input. But in general, if it's not specified, we do not consider Q dot, we do not consider W dot. Okay? So basically, if it's not specified, the special condition, if the special condition is not specified, we will use those 2 equations to analyze the mass flow rate and the energy of the system. Now we will practice an example 5.6, but we will do it in another video.